viscosity is really
Video?
zero.
Hi.
Take your time.
Are you video?
I'll
help him, yeah.
That's the edge of water, and you put that distance in. Then you would move over, in this case, let's say you move over another foot. The water, you take a look at the depth of the water, and it looks like it's about 0.6 inches. So you would set this so that you're at 6/10 depth. And again, you would be, you put the distance in, the depth in, and then just push measure, and it will do a count. Let me get this turned on. Unfortunately, I don't have it turned on right now. So let me cut to the chase and get into the middle here. We'll just take one quick measurement out in the middle. Here we're at about 6 inches depth. So I set this at 6, and I won't put any other input, but I'll just push measure, and now it's counting the revolutions. And again, the stream is pretty muddy, but indeed, you can see it is spinning. One revolution represents the passage of 1 foot of water. So right now we're at 20 seconds, and we're about 42 revolutions. So we're running at about 2 feet per second. Our rough what was our rough calculation when we did the
Three.
Again, you'll probably find a point in here where it is that high. And again, we did hit a chute up there is where we started. So what this tells us for this particular measurement, we're at 1.9 feet per second. So you could record where it is, where you took your last measurement, where you're going to take your next measurement, the depth, and you would then calculate it at each of these boxes. Any questions? Now, one of the other fellows, I guess your class just received a vernier propeller instrument. It basically does the same thing. I think it's for 1 revolution for 1 foot of water passage. You'd have to record all the parameters if you wanted to take a series of measurements. But and I'm not sure what came with what paperwork came with that instrument. The next step would be in this process is if I were out in the Salmon River, and typically I go out to the Salmon River during the summer and make a series of measurements, is rather than go out there every week and make a measurement, which takes an hour, you would, in a bigger stream, you would put what's known as a staff plate. You'd actually put a ruler stuck into the stream. You set it in concrete so it's not going to move. And when you come out to the stream and make your stream flow measurement, you would read the staff plate. So it said 1.4 feet or something. You would record the flow in the stream, and then you would come out once a month for a year and make a set of measurements, and then you would make a plot. Every time you made the stream flow measurement, you would read the staff plate and plot that on a log plot, and you would come up with a rating curve, which shows a relationship between the flow and the depth of the water. So that any time I came out here on this stream or whatever stream I'm working on, I just have to read the staff plate, and I would have a rough estimate of what the stream flow is. If you're interested in finding out more about rating tables and stream flows, you go to the USGS site, U.S. Geological Service,